So in this lecture, we will continue to how to find the moment of inertia for some important system, right? For example, we will try to solve few examples of the moment of inertia, right? For example, did you remember if this is the solid sphere, what is the moment of inertia? You tell. For the solid sphere, what is the moment of inertia? Tell me. Say 2 by 5 and the hollow sphere 2 by 3 mr square, right? So if I ask you to find the moment of inertia, right, this is the center of mass about an axis passing through its tangent. Can you find the moment of inertia of the solid sphere of mass m, radius r, about an axis passing through its tangent, right? So I you have to find. All right, so how to find this? Listen one thing. To find this, what you have to do, you have to draw an axis, right, passing through the center of mass which is parallel to this axis, right? So what is the ICM here for the solid sphere? Say 2 by 5 mr square. And what is the D? Here the D is equal to the radius. So what is the I? According to parallel axis theorem, I is equal to ICM plus M into D square. So what is the ICM? Say 2 by 5 mr square plus M into R square. So the answer is 7 upon 5 mr square. Are you getting or not? Right. So you can copy this for solid sphere. If you consider this is the hollow sphere. Find the moment of inertia about an axis passing through its tangent like this. This moment of inertia you have to find. This is the center of mass moment of inertia. Copy this. So what is the moment of inertia of this hollow sphere? You tell. The hollow sphere moment of inertia using the parallel axis theorem. I is equal to what? Say ICM plus M into D square. So ICM is 2 by 3 mr square, right? Mr square plus mr square. So m, because it is D, what is the distance between the two axes? So mr square. So this is 5 by 3 mr square is the correct answer, right? So this is the moment of inertia. Are you getting or not? For example, if I take an system of solid sphere, these are the solid sphere. The three solid spheres are there, right? These are the 1, 2 and 3. And the axis is passing through this. The each three solid sphere. And each of mass m and the radius is r, right? So you have to find the moment of inertia about a dash. You have to find this. These are the three solid sphere. Copy this. So how to solve these questions? These are the three solid sphere. If you consider this the 1, 2 and this is the 3. So if you consider the one solid sphere, this is the one solid sphere, right? So about an axis, what is the moment of inertia about this axis? We have found for the solid sphere ICM plus mr square. That is the moment of inertia of this solid sphere is 7 upon 5 mr square, right? And for this, what is the moment of inertia? Yes, 7 by 5 mr square. And but what about this? For this, 2 by 5 mr square. So what is the answer? So the I, yes, this is what? 7 14 और 16 by 5 mr square. Is it clear or not? Right. So this is the way how to find the moment of inertia of different system. One typical question may come from this to find the moment of inertia, right? Copy this. So okay, so these are the so many cases. We will continue to discuss this, but before this, the one more important definition I will explain, and this is the I will try to explain the radius of gyration. Is it covered in your coaching or not? You tell. Radius of gyration, right? Radius of gyration is okay, but you have to do radius of gyration. right? Because it is a simple concept and you can understand. What is the radiation of gyration? It is a distance. It is what? It's a distance from axis of rotation. From axis of rotation. Radius of gyration is only a distance from axis of rotation, such that, listen one thing, suppose this is a big mass, suppose this is a big mass, right? And this is the axis of rotation. And if this is the big mass, right, it is a solid body or some other system of discrete point masses you can consider. Now the moment of inertia about this axis is what? Say I. Suppose this axis is A dash, right, and the A dash is I. Are you getting or not? So what you have to do, you have to take, you have to assume, suppose the mass of this body is, suppose the mass m. So from same axis of rotation, from same axis of rotation, you have to put the mass of the body at a distance such that the moment of inertia of, so you have to find the radius of gyration for the different cases. For example, listen one thing. Suppose this is the disk, right? This is the disk. And this is the axis of rotation, right? So about this axis of rotation, you have to find this is the disk. Disk mean the mass and radius are. What is the moment of inertia? Can you tell? Speak fast. mr square by 2. And if you want to find the radius of gyration about the same axis, right, so what you have to do, just put it equal to mk square. That's it. Find the moment of inertia. You have to find that distance where all the mass of the body is supposed to be concentrated, such that its moment of inertia is same as that of the body about the same axis. So will cancel out, and r square by 2 is equal to k square. So what is the k? Say r by 2. This is the radius of gyration. Understood? So it is very simple, right? Suppose this is the solid sphere, right? Solid sphere. What is the moment of inertia about this axis? About this axis, the moment of inertia is 2 by 5 mr square, right? It is solid sphere, right? And for this solid sphere, if you want to find the radius of gyration, what you have to do? Find the moment of inertia and put equal to what? Say mk square. So will cancel out. Say k is equal to r 2 upon root 5. That's it. So for the different type of the system, when you are finding the moment of inertia, just put equal to mk square, and k is the radius of gyration. Radius of gyration mean, what does it mean? Listen one thing. Suppose this is the system. About this axis, if the mass of the solid sphere m, so I can assume that this mass is placed at distance k is equal to, right, this is the distance where all the mass is supposed to be concentrated, and when it will move, right, so it will produce the same moment of inertia which is being produced by this solid sphere about the same axis. So what is the radius of gyration? Radius of gyration is nothing but distance from axis of rotation, such that all the mass of the body is supposed to be concentrated at this point, such that the moment of inertia is same as that of produced by the body. Do you understand? Copy this. Okay. So different type of the system, if you find the moment of inertia put equal to mk square, then the radius of gyration you can find, right? So it is so simple. For example, suppose this is the rod, right? This is the system of rod. This is the one rod, this is the another rod. Okay, so can you, this is the rod of length L and this is the rod of length L. Are you getting or not? The mass is m, the mass is m, and the axis of rotation is this. This is the axis of rotation, and this two rods are joined like this in the shape of L, and it is moving like this. So you have to find the moment of inertia about this axis of rotation. Also, when you find the moment of inertia, then you also find the radius of gyration, right? So that is the thing. Do you understand the question? Copy. So what is that? Listen one thing. We have the two rods, This is the one rod. Listen, if I ask you, if this is the one rod only, right? If this is the single rod, moment of inertia is a scalar quantity and the moment of inertia will be added or subtracted according to the scalar quantity, right? So if this is the rod M of mass M and length L, can you tell me what is, this is the one rod and this is the second rod. Can you tell me what is the moment of inertia of this rod? About
mass square by 3.
ml square by 3. So this is ml square by 3. Only what is left? Only the other rod is left, right? Like this. So this is the center of mass. Listen one thing. Where is your axis of rotation? Just remove this, right? And just connect by a simple line this. So this is the rod, right? These are the rod like this. And this is the axis of rotation. And this system is rotating about this. After some time it become like this, right? Then this. Do you understand this or not? Right. So this is the system, one rod, two rod, and this is the axis of rotation. It is rotating like this. Are you getting?
Yes, sir.
So this rod is very easy to find the moment of inertia ml square. What about this? How to find? I am giving few examples, then remaining you will do by yourself. This is the axis of rotation or not? Yes. So take another axis which is parallel to this axis and passing through the center of mass. Are you getting? So now these are the two axes. So if we are able to find the moment of inertia about this axis, ICM. So can you tell me for this rod what is the ICM here?
Mass square by 12.
Yes, ICM is ml square by 12. Very good. And these are the two axes. This is the one axis, this is the another axis. So what axis theorem we will apply? Say parallel axis theorem, right? Because these are the ICM we know. We have to find this moment of inertia. So what must we know? We must to know this distance. If this is L by 2 and this is L, so what is this distance? The D is root over L square plus L square by 4. I think you are getting root 5 L by 4 is the distance, right? By 2. Is it clear or not? So for the second rod, right, IAA dash, this is the axis AA dash, right? So what for the first rod, what is the moment of inertia? Say ml square by 3. For the second rod, I will write the ICM plus m into d square. Is it fine or not, you tell?
Yes, sir.
Right. So ICM for this rod is what? Say ml square by 3. This is for the first rod. It is ml square by 12. Very good. Plus m into d square. M into d square. This is the distance between two parallel axes. So d is this. So m into root 5 L by 2 whole square. Right. Now we can simplify and we can get the answer. What is that? IAA dash is equal to ml square by 3 plus ml square by 12. This is the ICM plus 5 ml square by 4. Is it clear? So the 12 is the LCM. This is 4 ml square. This is ml square. This is 3 5 या 15 ml square. Right? तो कितना हो जाएगा? 20 ml square by 12. Right? So this is 4 5 20 ml square. So this is the moment of inertia. Are you getting or not? So if you are able to find the moment of inertia, how to find the radius of gyration? You tell. To find the radius of gyration, what we have to put? Equal to
mk square.
mk square. But in this case, what should be the m? What is the mass of the system?
2m.
2m. So we have to take 2m. This is the important thing. Right. So mass will cancel out. So 5l square by 3. 2k square, k is equal to L root 5 by 6 is the correct answer. So this is the radius of gyration about this axis. Listen, only the one more extra step you have to do for the finding the radius of gyration, because sometime in the question also the radius of gyration is given, or sometime the radius of gyration is also asked in the question. So just you have to put equal to mk square. Copy this. So any doubt you want to ask here? You tell. Listen, Okay, listen one thing. For example, if there may be the another system like this, right? There is a system of the rod like this, right? This is the system of the rod like this. This is the swastik sign, right? And each is rod of mass m, length l, right? You have to find the moment of inertia about this axis, right? So can you find the moment of inertia about this axis? Yes. How to find? Listen, this is the L, this is the another L. So although we have found the moment of inertia for this is ml square by 3 and this is the what is the total moment of inertia was coming? You tell. It is, tell me, 5.
5 by 3 ml square.
Yes, 5 by 3 ml square. So if there are 4 rods like this, so and the mass m, right? Mass m. So what is the total moment of inertia? Say 4 times 5 into ml square by 3. And when they ask the radius of gyration, so it is very simple. What you have to do? You have to put, say, mk square. But what is the total mass of the system now? It is 8m into k square, right? So the k square is equal to L, right? L square 20 upon 3 into 8, 4 दूनी 8, 4 पंजे 20. So k is equal to 5 root 6, right? L square L, right? This is the radius of gyration. Are you getting or not? So the radius of gyration is same as that it found in the previous case. So this question is asked, right, in the NEET and JEE, right? Copy this. Okay, so we have the 4 rods, right, like this, and these rods are arranged like this, and the moment of inertia of this rod we have to find in this way, right? So this is our axis of rotation, and this system is rotating like this. Do you understand or not? Right? Help. Yeah. Do you understand this thing? Should I explain? Yes. In the 3D view, these are the rods like this, right? These are the rods, right? Rods. So this is the axis of rotation. So the axis of rotation may be changed. Sometime they may ask with respect to this also. So again, you have to find the moment of inertia. So for different axes of rotation, you have to learn how to find the moment of inertia. And when we will proceed, right, for the next concept, right, torque and the rolling motion, then all this thing will be used, right? But here, this is the point. The center of mass is of the system is this, and with respect to this axis, with you have to find the moment of inertia. Are you getting or not? A dash you have to find, right? So how to find the moment of inertia? Listen one thing. If you consider this the rod, this is the one rod, right? This is the one rod, and you have to consider only the first one rod only, right? And this is the axis of rotation. This is the center of mass. So with respect to center of mass, right, it is rotating like this. We have to find the axis. We have to find the moment of inertia of this single rod about this axis. So with respect to this axis, we take a parallel axis and up to center, passing through the center of mass. So what is the moment of inertia of the ICM of this rod? Can you tell?
ml square by 12.
Very good. And what is the perpendicular distance between the two axes? What is the perpendicular distance? What is the distance?
L by 2.
L by 2. Right. So this is D is equal to L by 2. So for the one rod, only one rod about this axis, you know the ICM, you have to write this I. For the single rod, you will write the parallel axis theorem into MD square. So ML square by 12 it is, right, plus M into L by 2 ka whole square. Then you will simplify, you will get ML square by 3. Is it clear or not? So, but how many rods are there? Say 4. 1, 2, 3, 4. So what is the total I, A dash? You tell. Yes. 4 multiplied by ml square by 3. It is equal to 4 by 3. ml square is the I A dash. And somebody asked radius of gyration. It is very simple. Put it equal to, yes, put it equal to what?
4 mk square.
4mk square. So kk will cancel out. K is equal to what? Say L√3. This is the radius of gyration. Copy this. Wait for 1 minute. You asked me the moment of inertia. Okay, so this question we will continue, but for the cone, right? This is the hollow cone, and this is the solid cone, right? I'm writing the moment of inertia, although we should do the derivation for each and every part, but right now we are not doing this because half an hour it will take, right? So for the hollow cone, if this is the radius r and this is the height h, right? So about this axis, the moment of inertia is half mr square. Is it clear or not? And this is the solid cone. You must remember the moment of inertia, if it is rotating like this, it is equal to 3 by 10 into mr square. You have to remember this, right? 3 by 10 mr square is the moment of inertia for the hollow cone and for the solid cone. One more thing, right? About the diameter of the base. Suppose this is the symmetric axis. What axis is this called? Say it is symmetric axis. Why it is symmetric? Because this axis is symmetric. Another thing about the diameter for the hollow cone, about the diameter of the base. Diameter of the base means this is the axis of rotation and this cone is rotated about this axis. You understand this thing or not? So you have to remember this thing is equal to 1 by 4 mr square plus 1 upon 4 mh square. 1 by 4 mh square is the moment of inertia. This is the height h of the hollow cone and this is the radius r. Do you understand this thing? In the same way, for the solid cone, about this diameter, right? The moment of inertia is, if this is the 3 by 10, so just double. It is 3 by 20 mr square plus, right, 3 by 5 mh square, right? I'm writing here, if this is the solid cone about this axis, this is the moment of inertia about this symmetric axis, just double, just half of this, right? And this is the 3 by 5 mh square, right? So this is the answer. You have to remember these moment of inertia. Copy this. So this is the one more question, right? For you have to remember one more point for the hollow cone and the solid cone. Although generally this moment of inertia is asked, but I have also written about the diameter, right? One more thing, that is triangular right angle triangular lamina, right angle triangle lamina. For example, if this is the lamina and this is the A, this is the B and this is the A, right? And you have to, this is the right angle triangle lamina, so you have to find the moment of inertia about this axis. Is it clear? So this is the lamina and it is rotated like this. You have to remember this moment of inertia is ma square by, if you assume this is to be h, right, mh square by 6 is the answer. And how does it come? I will try to explain, right? For example, listen, if you want to find the moment of inertia, right, about this axis, so at distance x, the total mass is m, right? At distance x, you may assume the elemental portion of dx, right, and the mass is dm. About this axis, you have to find the moment of inertia. So we cannot write the moment of inertia for all this triangular lamina, but if I consider with respect to this axis, right, this is the dm mass, right, like this is the dm mass, it's present at distance x. So what is the elemental moment of inertia for this elemental portion? So di is equal to dm into x square. Is it clear or not? right? Now we have to integrate this and we can find the moment of inertia. Listen one thing. How? Because if you able to write the moment of inertia for this portion, then so many elements will be there from x is equal to 0 to x is equal to h, right? So if we add all the moment of these elemental moment of inertia, that is for this di1, di1, this is di2, right? Like this is di3. So how to find the moment of inertia? To find the moment of inertia, di1, di2, di3, like this, you have to all the add, you have to add all the moment of inertia. That is, this is the summation of all di's. Summation mean the integration. So this is the application how to find the moment of inertia of this type of the body using the integration. This is the integration how to apply. Integration mean the addition of all the elements parts, small parts, you have to add. And what is the moment of inertia? It is dm into x square. Now the problem is again, in the integration there are two variable. This is the x which is varying, this is the dm also varying. So what you have to do, you have
Write
to,
dm x
in terms of m, in terms of x, how to do? This mass is distributed over the
area
area. So what is the area of this uh,
half b
half VH? The mass is what? Say m. For 1 meter square, what is the mass? Say m
b by
upon
h.
BH. And what is the area of this thing? Listen one thing. Uh, this is the B, this is theta, right? If this is x, so what is this distance? Say h minus x. Are you getting or not? And if I assume this distance is yb, so what is the dA? You will write dA, you will write the length into width, y into dx. Are you getting this thing or not?
Yes, sir.
So what you have to find? You have to find this y in terms of x. So how to find? Listen, tan theta. What is the tan theta? Tan theta is equal to b by h, and tan theta is also equal to y upon
H minus x.
h minus x. So what is the by here? B upon h into h minus x. Is it fine? So what is the dA? So dA is equal to y into dx. This is the elemental area. And what is the value of the y? B upon h, h minus x into dx. So this is the elemental area dA. First copy this, then I will explain step by step. Listen one thing. This is the right angle triangular lamina, the moment of inertia about the base. Listen one thing. For example, if we have, this is the lamina like this, right? This is the triangular lamina. You may consider this the triangular lamina like this, right? And the height is h, right? This is the axis of rotation. This is the base. About base, we are rotating this such that the height is h. Are you getting? So about this axis, the mass is m, you can consider. This is the h, the mass is m, right? So what is the moment of inertia about this axis? A dash. Again, the a dash is equal to 1.6 mh square. It comes same, mh square. I can prove this, or I can explain this, how they are equal, right? For example, listen one thing. If you consider this is the one portion, this is the right angle triangular lamina. Suppose this is the M1. So if this is the height h, so for this body, right? For this left side, what is the moment of inertia you will write? Say 1 by 6 m1 h square. Are you getting or not? I1 is equal to 1 by 6 m1 h square, right? If you consider the another portion, right? This is the portion. If you consider this is the portion, are you getting? About this axis of rotation, I2, the mass is supposed to be m2, the height is h2. What is that? 1 by 6 m2 into h square. Is it clear or not? You tell.
Yes,
Right? If you join them, what is the moment of inertia? You tell. The total moment of half,
m1 plus
yes, 1 by 6 m1 plus m2 h square. Is it clear or not? And the total mass is what? Say m1 plus m2. So this is equal to what? 1 by 6 mh square. So this type of the moment of inertia for this type of the lamina, whether it is right angle or not, right? This is the lamina and the mass is m. Suppose this is the h. So about this axis, what is the moment of inertia? Say 1 by 6 mh square. Do you understand this thing or not? You tell. Right? Copy this. So if you know this 1 by 6 mh square, so yesterday I have given you the questions, right? Listen one thing. Suppose it is the square plate, right? If this is the square plate, I think the side is A, this is side is A. You are able to explain the moment of inertia about the diagonal. What was that? You tell. What is the moment of inertia about the diagonal?
MA square by 12.
Ma square by? Yes, ma square by 12. Because what is the moment of inertia about this?
MA square by 6.
You have to remember in this way, right? Right. And also you know the concept, how does it come? Listen one thing. Yesterday, if I assume this is the x-axis and y-axis, this is the 90-degree, that is why we are able to apply the theorem of perpendicular axis. But I had given a one question. For example, suppose this is the side A, right? This is the side B, and if I ask, this is the mass m, what is the moment of inertia about this axis? About this axis, AA dash, right? Now you have to find the moment of inertia about axis in the passing through the center of mass and passing through the diagonal, right, along the diagonal and in the plane of this rectangle lamina, right? This is the question. Copy this first. Same concept we are going to apply to find the moment of inertia, right? For example, if you choose, this is the lamina, right? This is the lamina, triangular lamina, and this is the base, suppose, right? So if the mass of this lamina is m dash, right, and if you are able to find this height h, then you can write the moment of inertia. So what is the moment of inertia about this axis? You tell. 1 upon 6 m dash into h square, right? Are you getting? So how to find the h? Can you find the h? Listen one thing, I am telling you. What is the area? The area is 1 by 2. What is A into B, right? If this is B and this is A, what is the base length? Say root A square plus B square. And this is the h. So the same area can be found is equal to 1 by 2 base into height. Is it correct or not, you tell? So what is the h? Is equal to AB upon root over A square plus B square. So in this way you can find the perpendicular height, although there are so many methods. If you assume the theta and the tan theta, sin theta, like that, you can also find. So it looks better for me, so I do like this, right? Otherwise, applying the sin theta and you can find this. So what is the m dash, you tell? The m dash is m dash. What is the h? Say AB upon A square plus B square का whole root. 1 by 6 m dash A square B square upon A square plus B square. Are you getting or not? This is the h. 1 by 2 AB into 1 by 2 base into height. This is the height. So this is the IA dash. Is it clear or not?
Yes.
And the same moment of inertia of this second portion also. So what is the I'm writing this is the I only, right? I dash only, right? So IA dash will be equal to say 2I dash. This is the I dash of the one rectangle lamina. 2 into 1 by 6. This is the m dash. What is the m dash? Is the m by 2 a square plus b square by a square plus b square. It will come 1 by 6 m into a square b square upon a square plus b square. So this is the moment of inertia about the diagonal for this rectangular slab about the diameter. Are you getting or not? You tell. If you put a and b are equal for the square, so what will you get? M a square upon 2a square. So m a square by 12. The same answer you will get for the square. So this is the thing you have to remember. A square b square upon a square plus b square. 1 by 6 m a square b square upon a square plus b square. Copy this. Suppose this is the rod of length L, mass m. What is the moment of inertia about this axis? Tell. Say ml square by 3. Right. Now, if this rod, initially this rod is what? Rotating like this. This is the axis of rotation and it is rotating. Now, if this rod is tilted by some angle like this, right? The length L, mass m, angle is theta. This is the axis of rotation, right? And now this is the axis of rotation and this is the rod. Initially the rod was rotated like this. Now the rod is rotated like this. Do you understand this thing or not? It is rotating in this triangle like this. So you have to find the moment of inertia of this rod about the axis AA dash, right? How to find? Listen one thing. If this is the ml square by 3, if all the rod is present on the axis, then what is the moment of inertia? You tell. Say 0. Is it clear or not?
Yes, sir.
Why it is so 0? Why it is 0?
It is around the axis of rotation.
Yes, the moment of inertia is mr square, and if all the mass is present on the axis, so what is its r? Say 0. So moment of inertia will be what? 0. Are you getting or not? So listen one thing, to find this moment of inertia, although we can do by integration, but we are not by the symmetry we can solve this. What is its effective length perpendicular to the axis? What is effective length? If it is L, what is this length? Say L sine theta. That's it, right? And this is the axis of rotation. So if this is the mass m, the effective length is L sine theta. So what is the moment of inertia? 1 by 3 m L sine theta square. So 1 by 3 m square L square sine square theta. Right?
M9 square.
Yes. 1 by 3 m L square sine square theta. Sometimes the question they give like this. They give like this. This is the theta. Also this is the theta. Right. The rod is, suppose this is the L1 and this is the L2. And the total length is what? Capital L. Then what is the moment of inertia about this axis of rotation? You tell. They may give the theta. Right. Tell me. Say
1 by 3
sine square theta only. Listen. So the effective length of this portion is what? Say L2 sine theta. Effective portion of this length is what? L1 sine theta. Right. So what is the effective length? Say L1 sine theta plus L2 sine theta. Are you getting or not? Like this. So the moment of inertia again is what? 1 by 3 m L1 sine square theta. Right. L1 साइन स्क्वायर m1, तो इसका भी m1 ही आएगा, m1 L1. So you can write the length is what? It is better to write the total length sine theta, right? So 1 by 3 m and L1 plus L2 is what? Say L sine theta. So the L sine theta is the answer only, right? 1 upon 3 ml square sine square theta. The same answer you will get. Are you getting or not? Copy this. Listen one thing. before doing this question, a simple question of truncated body, how to find the center of mass of the truncated body, right? Listen one thing. Suppose this is the disk, right? This is the disk, and this is the disk of mass m, right? And the radius r. This is the disk of mass m, radius r, and another disk is cut out. Another disk is cut out from this solid disk, right? And whose radius is what? Sorry. Whose radius is what? Say r by, this is r, and this is r by 4. Are you getting? So you have to find the moment of inertia, find moment of inertia of remaining portion about an axis AA dash. This is the question. AA dash. Initially, before cutting, what was the moment of inertia about AA dash? You tell, say 1 by 2 mr square. Now some portion is removed, you have to find the moment of inertia of remaining portion. You understand this thing or not? You tell. Copy this first. So how to solve this question? Listen, moment of inertia is a scalar quantity. It is added and it is subtracted. If some portion is added to this disk, right, the moment of inertia will be added. If some portion is removed, so what is the removed portion? You tell. This is the removed portion. The mass m dash. Can you find the m dash using a unitary method, right? What is the total mass of what is the total area? So the mass is distributed over the area m, 1 meter square m upon pi r square. What is its area? The radius is r by 4, pi into r by 4 whole square. It is equal to m upon pi r square into pi r square by 16. So what is the m dash? The m dash is m upon 16. Is it clear or not? You tell. So you have to subtract the moment of inertia of this portion which is removed. Listen one thing. If this is the axis of rotation and it was the disk, right, which is removed from here. So if it is the center of mass of the disk, so can you find the moment of inertia of this removed portion about this axis? Yes, using the parallel axis theorem. Suppose this is the moment of inertia of this removed portion is ICM, right? So what is the ICM, you tell? What is the ICM? The ICM is half m dash r square. What is the r? R by 4 whole square. So 1 by 2, what is the m dash? Say m by 16, r square by 16. So what is this? This is 512, right? 256 into 2 512. So this is the ICM, but we have to find IIA dash. So the moment of inertia of removed portion is what? Say ICM plus m dash into d square. Are you getting or not? What is this? Say m dash. What is the d? Can you tell me what is the d? D. Very nice. Because this distance is what? Say r by 4, and this is the d, and total is r. So what is the d? R minus r by 4. So 3r by 4. I think you can do that now. Copy this slowly, right? And how to solve this ICM? This is the ICM, the m dash. So I removed portion is equal to ICM. What is that? Say mr square upon 512 plus m dash. M dash is what? M by 16 into d square. D is what? 3r by 4 whole square, right? So 4 चौक 16, 16 16 256. So mr square upon 512, right, plus 9 mr square upon 256. So this is 512 mr square plus 18 mr square. So this is equal to 19 mr square. 19 19 mr square upon 512. So this is the moment of inertia of removed portion. So what is the moment of inertia of the remaining portion, you tell? So initially the moment of inertia what? Say half mr square minus moment of inertia of removed portion. So half mr square minus 19 by 512 mr square is equal to what? 512 256 mr square minus 19 mr square, right? So 256 and 19, 16 में से 9 गया, बचे 7, 4 में से 1 गया, बचे 3 और 237 237 upon 512 mr square is the moment of inertia of remaining portion. So this is the way to solve this question. Are you getting? Copy this.